So as we approach today, all right, two skills that we need are, we need to be able to simplify radicals. Ka-chow, we already have a background on that. But here we're also going to simplify radicals in a different context. Whenever we see radicals and fractions, there has to be certain truths to be told. One thing, whenever we have a fraction, is we have to say no to decimals. We have to say no to fractions inside a fraction, generally. And we have to say no to radicals in the denominator. So no radicals in the denominator. So our goal when we're simplifying these is that we have to get the radical out from the denominator. So that method is called rationalizing the denominator. Rationalize the denominator. Rationalize the denominator. In other words, let's make the denominator essentially a whole number. So technically it should be integerize the denominator. But all right, so how do we do that? It's actually very quick. All we have to do is take exactly what we see, the radical 2, and we're going to multiply it by itself. Now remember, with fractions, whatever I do to the bottom, I have to do to the top in terms of multiplying or dividing. So that means I have to multiply the top by radical 2 as well. Now we start to simplify. The numerator, 3 times radical 2 is exactly that, 3 radical 2. And the denominator is radical 2 times radical 2. And just to give you a heads up, that jumps straight to 2. Where did that come from? Well, if I were to say radical x times radical x, that's the same thing as saying radical x squared. And notice that the square kills the radical, so we're just left with the number that's inside the radicand there. And so we end up getting just 2. So feel free to jump to this right here. Radical 4 times radical 4 is 4. Radical 8 times radical 8 is 8. If you wanted to, you would have to do this, radical 4, and then jump it up. So that goes to there, and then it simplifies to there. But again, that's the point. The whole point of this is to get rid of the radicals in the denominator. We're allowed to have radicals in the numerator, no problem. All right, so what are we going to multiply this one by in order to start the process? So radical 3, top, bottom, right here, radical 3, radical 3. And now we start to simplify radical 3, 3 radical 3 for the numerator, and 3 in the denominator. What else happens? Now, here's something about the nature of simplifying. Radicals here and a radical down here can simplify their insides. And the coefficients or constants can simplify, but one can't simplify one side the other. So like this radical can't simplify with this whole number. So essentially we're reducing things that are in a like position. Both of those are outside the radical, so we can simplify them. So my final answer here is actually radical 3. All right, let's take a gander at these next problems here. We're going to walk through 6 problems to see what pattern emerges. And that's called inductive reasoning, where we see a pattern and then we make a conjecture about it and prove it or not. All right, so here we want to find the value of the hypotenuse x, which means x is the longest side of these, if these are 3 sides of a triangle. So what do? We say 10 squared plus 10 squared equals x squared. Now, I get 100 plus 100 equals x squared. 200 equals x squared. And now when I take the square root of both sides, remember that it is true that the square root is positive and negative, but I'm dealing with distance, so I will only consider the positive version of that. Now the radical 200 needs to simplify, blah, 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 radical 10 radical 2. So keep that number in your head. Keep that number in your head as we start to look for a pattern. Now with your partner, please do BC. Just to check your work on this one here, after you simplified this one, you get 3 radical 2. And after you simplify this one, you get 5 radical 2. And what pattern starts to emerge? All right, so let's follow through with D now and look for a separate pattern here. Now again, we're told that x is the hypotenuse. So I'm going to say 5 squared plus 5 radical 3 all squared. We'll have to simplify that by distributing that 2, essentially, x squared. Now, 5 squared is 25. And a rule of exponents says when you're multiplying, the exponent can go into all factors, every single factor it goes into. So it's sort of like the distributive property, but or a distributive property of exponents of sorts. All right, so that's going to be 25 times 3. Again, the radical annihilates the square there. Equals x squared. So I'm going to simplify all that to be 100, x squared, and then when we simplify that, or solve that, and keep only the positive, x is 10. So keep that in mind and see how it might relate to the other ones. Now pause and do EF for a quick. All right, x here is 20 for E, and x here is 14 there. So let's see, and 2 patterns that will emerge. The first pattern, it's called a 45-45-90 triangle. Sometimes it's called a 45-45 right triangle. You might hear it called something like that. Sometimes it's called an isosceles right triangle. All of these are equivalent in terms of using the rule. Okay, so in a 45-45-90 triangle, the hypotenuse is radical 2 times the leg. Now from that, we will unpack it. If we know the leg, we have to kind of go backwards. That's sort of a division that goes on. All right, and this other one in a 30-60-90 triangle, which, by the way, a 30-60-90 triangle is half an equilateral triangle. It's half an equilateral triangle. The hypotenuse is twice as long as the short leg, and the longer leg is radical 3 times the short leg. And that already says that. Salud. Radical 3 as long, or radical 3 times as long as the shorter leg. So there are 2 ways that we're going to consider this. The first way that I'm going to show you is you can always just set up this proportion right here. The moment we recognize that it is a 45-45-90 triangle, I can always set up this proportion. 1, 1, radical 2. And turn those into the denominators of 3 fractions. And what we're going to do is place the leg, and the hypotenuse. Notice that these are small, and this is the longest one. Small, small, long. Because radical 2 is about 1.4, so we see that that's longer, so the longer one's going to correspond there. So what we do is this. Here's the length of a leg, we put it there. Here's the length of a leg, we put it there. And here is the x, the hypotenuse goes right there. Now what we can do is just make a proportion, and a proportion only needs 2 fractions, and we can solve this. Remember, you can just do cross multiplication, and in this case, it's fairly straightforward. If I do cross multiplication here, I get 8 radical 2 equals x times 1, or simply 8 radical 2. Now, when you know the leg is 8, how do you actually get, what would be a faster way just to get up to there? What you can simply do is just take that 8 and multiply by radical 2. Multiply by radical 2 to get to the longer. Which means, conversely, if I know the hypotenuse, to get to a leg, I have to divide by radical 2. And we'll unpack that in the next example here. So notice here, how do I approach this one here? Well, one way to approach it is 1, 1, radical 2, like this. Set up my proportion. X's are my legs, so they go there. And 15 is my hypotenuse, so it goes there. Notice here that x over 1 is x. It's done. x over 1 is already x. So all I have to do now is rationalize this denominator here. Rationalize this denominator here by multiplying the numerator and denominator by radical 2. So bring down the x, 15 radical 2 over 2. Nothing else reduces. So that's my result. So in a 30, 60, 90 triangle, this one's a little bit more complicated because we don't have isosceles. We don't have the same. But we do have some things that seem to repeat. So it's going to look like this. One way to set it up is to always use this pattern here and turn it into a fraction that says with the denominators 1, radical 3, and 2. So this one is going to be the small, medium, and large. Small, medium, and large. Or the shorter leg, the longer leg, and the hypotenuse. But the small is 12 here. The medium is x. And the large is y. Now at this stage, all you have to do is cross multiply whichever. So notice here, here's one proportion, but what's wrong with this proportion? It has two variables, so I can't really solve that one very well. So if I were to solve this one, I could get x by itself. And the other option would be essentially to cover up this guy right here. So I'm dealing with the 12 times 2, the y times 1. So that's one way to do it. So let me go ahead and just set that one up here and go ahead and solve this. In order to get x by itself, I cross multiply. And we see 12 radical 3. But of course, your brains are saying, how do I get from here the short leg to the hypotenuse? What's my one simple shortcut? Multiply by radical 3. Notice, here's 12, and this is 12 radical 3. So, going in one direction, which means if we have to go in the other direction, if we have to go from the hypotenuse to the short leg, we have to divide by radical 3. So we have to undo that, and we'll look at a problem like that momentarily. All right, now the other proportion that we're going to use, the other proportion that I can use is just to delete this entirely, since we already have it, and do the 12 times 2 equals y times 1. So y is 24. Oh, and what was my mistake over here? I should have been going this direction, times radical 3. And this one is doubled, times 2. Which means, if I'm going the other direction, I have to divide by 2 from there to there. So y is 24, and x is 12 radical 3. So, one way to do this is just to set it up small, medium, large. Salud. Small, medium, and large. X is the small, so I'll put it there. 12 is the medium, so I'll put it there. And y is the large, I'll put it there. So you can just cross multiply however you would like. Now notice in this situation here, I can cross multiply, but remember, cross multiply is just a tool to get the variable by itself. Notice over here, to get the variable by itself, I have to just get rid of the 2. So in this proportion right here, which is 12 radical 3 equals y over 2, all I have to do is multiply by 2 here and multiply by 2 here to get the y by itself. So you can cross multiply. But then, of course, what else has to happen here? I also have to get rid of this radical 3. So while I'm here, get rid of the radical 3. There. So now I get... How would we approach something like number 9? Number 9, I don't have a right triangle. What I have, in fact, is, and I know it's true because that's 90 degrees here, that's 90 degrees, so these have to be parallel. So I do know it's a trapezoid. But my job is to find out what A and B are. How am I going to do that? Well, fairly straightforward. Go ahead. What we can do is draw essentially what we call the auxiliary line right there. And what we're saying is that it is parallel to the 11 radical 2. And therefore, I have a rectangle over here and a right triangle over here. So now I know that this is 11 radical 2 here. Now, b is the whole thing here, so I'll get to that in just a minute. But I do know, if I'm just focusing on this section here, this guy is the same size as this one here. It now makes an isosceles because of the 45. I know it's isosceles. So all I have to do is go from my leg, 11 radical 2, and multiply it by radical 2 to get here. So A is 11 radical 2 times radical 2. So that becomes 11 times 2. So 22 is what A is. Now, how are we going to get B? How do we get B? Now what we can do is take our 8 radical 2 and place it up there, and then our 11 radical 2 and place it there because of isosceles triangle. So we're going to add those two together. And then from there, we just treat these like terms, and we can add them together to be 19 radical 2, and there's our answer for B, and A is just 22.